Okay, so applying LeChateliers Principle. Really, LeChateliers Principle says if stress is added to a system, the system in equilibrium is going to adjust so as to relieve that stress. So an easy way to remember this is if you add a molecule, an ion, heat, it's going to move away from the side that you add to. If you take or remove a molecule from one side, it's going to go towards that side, because if you remove it, it's going to try to replace what you just removed. Okay, so a couple problems here. So what we've got here is we've got a system in equilibrium. First of all, we know it's in equilibrium because it has arrows pointing to the left and to the right. And so we have the forward and reverse reaction. Remember, in equilibrium, it's constantly creating these products. But then these products will recombine and shift to the left and create these products. So it's in constant motion. It's called dynamic equilibrium. Constantly moving. Now, currently there's no net or gain. We've got all of these compounds in this container. Constantly we're making the products and using those to form the reactants. And then constantly making the products, using those to form the reactants. All right, so we can shift the equilibrium. So let's do the first one, NH3. So first of all, here's the arrow indicating you're adding something. Okay, so I just use the up arrows indicating you're adding. So we add NH3. If we add NH3 and we're adding it to the left side, add goes away, so it's going to go away from the left side, okay, which is obviously has to be to the right. It's the only option. So what that means is if we're shifting to the right, that means we're making more of all of these. Okay. So we can put our up arrows down here. Now, what did we use? Where did we get this extra oxygen to make the nitrogen monoxide and water? Well, we got it from here. So guess what? That one is going to decrease. Okay. All right, let's try another one. Let's do a remove. All right, let's say now we're going to remove oxygen. So let's remove oxygen. All right, if we remove or take oxygen, it's going to shift towards. Okay, if it shifts towards, well, we need to figure out what happens to ammonia. We're making more of it. Okay. Then where did we get the nitrogen and hydrogen from? Well, we got it from water and nitrogen monoxide. So guess what? Those two are going to decrease along with heat. So direction of shift, fill these out. We remove, shifts to the left. Therefore, oops, that is going to increase. And those are going to all decrease. Okay, let's try one more here. Okay. Now, same thing with nitrogen monoxide. Okay, we add or remove that. Same thing with water. Let's try pressure. Pressure is going to shift. If you increase pressure, it wants to relieve that pressure. It's going to shift to the side with fewer gas molecules. So if we look on the left side, we have 4 and 5. We have 9 gas molecules. Right side, we have 10. And so if we increase the pressure, it's going to shift to the side of fewer gas molecules. So it's going to shift to the left. So those are going to increase. We have a shift to the left. Therefore, those are going to decrease. Okay? So if our arrow, shift arrow, direction of shift arrow is pointing towards them, they increase. If it's not pointing towards them, they decrease. Temperature. Well, temperature is heat. If you increase the temperature, what you're doing is you're actually just simply adding heat. So we add heat, When we add, it shifts away. So those two on the reactants are going to increase. And the two products are going to decrease. Okay, addition of a catalyst, remember that? No change. All right, so hopefully that will help you get started on this problem.